All right, we're going to graph a translation of the reciprocal function. So you guys already know how to do this. Let me just tell you that you already know how to do this. Let me show you why you know. So the graph g of x equals 1 over x minus 3, tricky x, plus 2 on the end, vertical. What are the equations of the asymptotes? What are the domain and range? So let's talk about the parent function, f of x equals 1 over x. That is the reciprocal function, parent function. All right, the domain and range, we talked about this in our other video, so we can just jot this down quick. The domain is your x's just cannot be 0, and the range is your y's cannot be 0. If you remember, those are the asymptotes. So we're going to sketch in, here's y equals 0, here's x equals 0. Your graph will never cross those points. Your parent function, oh, let's write, those are the asymptotes. Y equals 0 is that line, x equals 0 is that line. This would be called a horizontal asymptote because it's a horizontal line. It has a y equals equation. This would be a vertical asymptote because it's a vertical line. It has an x equals equation. Okay, so our parent function will go through two distinct points. It's going to go through 1, 1, because if I make the x a 1, 1 divided by 1 gives me back y, so I've got that ordered pair 1, 1. And if I use a negative 1 for the x, you will get a negative 1 for the y. So it will go through negative 1, negative 1. Now I know that we're going to approach our asymptotes without crossing them. So when I draw in the curves, I'm just going to come in alongside that one, hit that point, come in alongside that one. There's our first curve, and then we're going to do the same thing over where this point is. So that's the parent function. What changes when you have an x minus 3 tricky x and a plus 2 vertical shift on the end? So let's just identify the translations. That x plus 3, we're going to shift to the right 3 units. And that plus 2 on the end, we're going to shift up 2 units. So here's how we do the shifting. You're going to shift your asymptotes, and let's shift that, that 1, 1, negative 1, negative 1 point. So if I am shifting to the right 3 units, this vertical asymptote is going to shift to the right 3 units. When I move over to the right 3 units, it's going to be right here. The horizontal asymptote is going to shift up 2 units. So I'm going to redraw that, shifted up 2 units. It's almost like I'm redrawing the x and y axes where this is now my new origin. So remember, we have two distinct points. If I was at the origin here, it was over 1, up 1, and to the left 1, down 1. So I'm just going to find those same points with our new asymptotes over here. We've got this point right there, and then this point right here. Our asymptotes are, it says identify them. We've got y equals 2 and x equals 3. Let's go ahead and draw in our curves, and then we'll talk about the domain and range. So curves, again, we're going to go through that point, but we're not going to touch the asymptotes. We just come along the asymptote, head out toward it without crossing, and then same thing over here. We've got our curve. Let's hit that point and head toward that without crossing. So if you notice, our x's and y's will never cross those asymptotes. So your domain, all of your x's will be everything except for this 3. It says x equals 3. So our domain is our x's will never equal 3 because that was your asymptote. Your range, the y values, will never hit this horizontal line right here, which is y equals 2. So all your y values will never equal 2. And there we have shifted our parent function 1 over x to this right here.